Today we're going to dig into a question that might just make you rethink everything you learned back in science class. It's about a theory that's both totally fascinating and, well, pretty controversial. We're asking, is there really a fourth phase of water?
I mean, think back to grade school, right? It was basically burned into our brains. Water has three phases: solid, liquid, and gas. Ice, water, steam. Simple. But what if that's not the whole story? What if there's another state of water hiding right under our noses this entire time?
So this pretty radical idea comes from Dr. Gerald Pollack. He's a bioengineering professor at the University of Washington, and his lab has been studying water for decades. And what they've come up with is a huge claim that we've all been missing a crucial piece of the water puzzle.
All right, so what exactly is this new phase of water supposed to be? Let's break down the main idea. According to Dr. Pollack, this fourth phase isn't a solid, a liquid, or a gas. It's something in between. Just try to imagine a state that's way more ordered and structured than liquid water, but it's not frozen solid like ice. He describes it as having this kind of gel-like or liquid crystalline feel to it.
To really help you get your head around it, Pollack uses this great analogy he got from another scientist, Gilbert Ling. The idea is that the water inside our own cells isn't just sloshing around randomly. Nope, it's highly organized, structured, kind of like soldiers at attention. And really, that single idea is the foundation of his entire theory.
So, this special structured water needed a name, right? And the name they gave it actually tells you a lot about its most obvious feature and how they even found it in the first place.
They called it exclusion zone water, or just easy water for short. So why exclusion zone? Well, because when this phase forms, and it does this next to surfaces that love water, what scientists call hydrophilic surfaces, it does something pretty remarkable. It literally pushes other stuff out. It excludes tiny particles and even dissolved molecules, creating this little area of super pure water.
Now, supporters of this theory say, hey, this isn't just some vague idea. They claim you can actually measure the differences. They say easy water is thicker, more viscous, and about 10% denser than regular water. But here's the really big stuff. They say it carries a negative electrical charge. It's more alkaline, and it even bends light differently.
And this is where it gets really wild. Down at the molecular level. We all know water is H2O. Well, proponents of this theory claim easy water isn't H2O at all. They say its formula is actually H3O2, and instead of molecules just bouncing around randomly, it's supposed to form these neat, ordered hexagonal sheets, and that, they say, is what gives it that gel-like structure and that negative charge.
A snowflake is the perfect way to visualize this. That beautiful six-sided symmetry, that's just water creating a hexagonal structure when it freezes. So the theory is that easy water does the exact same thing, but it does it without freezing. It creates a similar, highly ordered lattice, but in a liquid crystalline state.
Okay, but a really big question here is, if you're building all this structure, where does the energy come from to do it? Well, according to the theory, the answer is,
The whole process is supposedly powered by radiant energy, like sunlight. Here's the rundown. First, you need one of those water-loving surfaces. Then, light, especially infrared energy, gets absorbed by the water right next to it. That energy is apparently enough to split the H2O molecules apart. The negative bits get together and build those ordered, negatively charged easy layers, while the positive bits, the protons, get shoved out into the rest of the normal water.
And here is the really big payoff of the theory. When you separate negative charges from positive charges, what do you have? You have a battery. The water literally becomes a tiny light-powered battery, storing energy it's soaked up from the light. I mean, just think about that. If it's true, the implications are just massive. It could change how we think about everything from cellular energy to weather patterns.
Now, here's a really important point to make. The initial observation isn't really in dispute. The fact that an exclusion zone exists, this layer of water near some surfaces that pushes particles away, that's been seen and replicated by other independent labs. The phenomenon itself appears to be real.
And this gets us right to the heart of it. The huge controversy isn't about what is happening in the lab, it's about why it's happening. Is it a revolutionary new phase of water, like Dr. Pollack proposes, or can it be fully explained by the physics we already know? That is the core of the scientific debate.
in the end, the story of the fourth phase of water is this fantastic tale of observation versus explanation. It really pushes us to question what we think we know about the most common, most familiar substance on Earth.
An amazing discovery or a scientific misstep? The debate is very far from over, and it's a powerful reminder that even in the subjects we think we know best, there are still some deep mysteries to explore.